My name is Brian Donnellan. I come from Ireland, from Maynooth University. Does the sound okay? Good. Okay, thank you. So I'm delighted to be here today to talk about recent technology developments and how they're impacting business and how they're impacting society. And I will talk about some emerging trends in the future of work and AI technology in particular. So as an introduction, just to describe to you where I'm from an old university in Ireland, Maynooth University. And for those of you who may not know where Ireland is on the west coast of Europe, and it's on the edge of Europe, if you like. And within Ireland, Maynooth is on the east coast. So we are located as a university just outside the capital city of Ireland, which is Dublin. So that's my home university, and that's the location and some background to where I come from. I work for the Innovation Value Institute. That is an institute based in the university. And the institute has been established in 2006 as a collaboration between Intel Corporation and Maynooth University. So we've been busy for the last 20 years looking at IT innovation and IT management issues. So we've done a lot of research on data, on AI, on digital transformation. We've attracted quite a significant amount of funding from the Irish government and from the European Union. We've done a lot of training, published a lot of papers, both academic and also practical papers. And we run lots of industry events with members. The highlight of the year is the annual IVI Summit, which attracts over 200 attendees from around the world to discuss IT-related issues. So that's the institute in the university where I work. This year, we're celebrating 20 years in existence. We have quite a varied community of collaborators within the institute. Private industry, also public service organizations in Ireland, in Europe, and throughout the world. So there's a big focus on practical research and practical application of technology. So a long association over 20 years with many of these companies. Our focus has been on a number of research areas: digital retail, smart cities, digital health, digital construction, GovTech, manufacturing, FinTech, and agri-tech. So these are the pillars or the research themes that we look at in our institute. And across those themes, we have a couple of cross-cutting areas of focus. One is digital strategy and vision, and another one would be digital capabilities and architectures, and finally, digital technologies. So those would be the cross-cutting activities that go across all of our focus areas. So to help us help external partners, we've developed over the last many years a model, an IT management model. That model is called the Capability Maturity Framework. And this is a framework to help companies and public service organizations to improve their capability in what area of choice they see fit. So it could be something around value management and business modeling, operating models, governance, innovation, and compliance, our workforce, people, skills, and trust. These are models that we have developed over the last 20 years to help people move in these areas and help them to become more sophisticated and more progressive in their use of information technology and other types of technology as well, of course. So that was a very brief introduction to the organization that I represent and the place that I work. I'm now going to talk a little bit about technology development, and the emergence of different types of technologies at different times in our history. So I guess it's not a surprise that there is a time constant when it comes to technological development and technological diffusion. And if we look back over mankind and our relationship with technology, there are waves of development that are fairly easily discernible and fairly easily described. And these days, of course, a lot of talk about emerging technologies such as AI and quantum computing and so on. And some researchers would claim that to understand where we're heading in the future with these technologies, we need to understand where we've come from. So if, for instance, we look at innovation cycles, we can see going back over the last couple of hundred years, there have been a number of specific innovation cycles and technology associated with each cycle. So that first wave, going back to the 1700s, was water power, textiles, iron, and then second wave was steam power and rail and steel. Third wave had to do with electricity and chemicals. Then the fourth wave was petrochemicals and electronics. And the argument today is around the fifth wave of digital networks, software, and new media. And then as we progress to the sixth wave, which is AI and Internet of Things, robots, drones, and clean tech. So there has been a steady progression of technological emergence that can be mapped in this type of a linear time model. One thing that is noticeable already from this graph is the fact that the waves are becoming shorter. So if you notice, the time for adoption and diffusion and dissemination of technology is decreasing. So this has an impact, we will see, on future technologies such as AI. But just note that the history of innovation cycles tells us that the time we have to adopt and diffuse technology is decreasing. Of course, we work in, certainly I work in the academic environment, and academic scientific research is also can be described in a time linear fashion. Going back to the original scientific researchers, they were reporting on observations in the first era of scientific research. And that those observations were put in equations that led to a theoretical scientific view of the world. And that became computational with the advent of compute power and computing in general. And then we had the application of data-driven science. And we're now in the fifth era, which is looking at how, as academics, as researchers, we can work with AI to improve our scientific approaches and scientific methods. When it comes to information technology, then, there is also a very clear mission, a clear history, a clear development trajectory for IT. You know, the first IT systems back in the 60s and 70s were based around a cost law developed by Grosch. And that was a very system-centric, very centralized system. The first computer that I developed programs for was an IBM 360. There was a time-sharing computer. a mini computer that was based in a computer center in the university. Then with the advent of Moore's law in the 1980s, Moore's law, you might remember, is the law that says that the number of devices in a transistor doubles every 18 months. And that becomes an enabler for the growth of PCs and microcomputers. So Moore's law drove that PC-centric view of the world. And then we had Metcalfe's law, which describes the impact of the number of users on a network. And that enabled a network-centric view of computing. Most recently, we've had laws of digital transformation that looked at cloud-centric views of the world, and based around software on demand and virtualization, there was a different type of usage model. Today, you could say that we're in the kind of convergence period of information technology, where social media and other types of online systems have enabled new types of digitized business. So we're in this convergence or AI-centric view of the world at the moment. So I guess my point is that as we look and examine current technologies, it's always good to understand where they've come from, what the lineage of the thinking was, how they have progressed from one another and developed from each other. And there is a school of thought within the research community that this type of modeling or view can help us make a better job of deploying AI or quantum or whatever the new technology might be. Okay, so we've looked at, firstly, the organization that I'm in, the Innovation Value Institute. Then we looked at how technology has transformed over the years and how it can be described as a series of waves, of technological waves. And one of the consequences of the information technology progress has been the enabling of digital transformation in organizations. So digital transformation has been enabled by these waves of technology development. In the IVI, when we talk about digital transformation, we think of three types of digital transformation, depending on the posture or the stature of the company. And depending on the ambition and how progressive that company is in terms of its positioning in the marketplace and so on. So the most gentle transformation can be an evolution and an adaptation. It can be a start of the journey, if you like. The next level of ambition is where you want to extend and migrate your systems. And a more dramatic one is when you want to do a significant system change and you want to modify the existing value constellations and value ecosystem in which you operate. And then finally, if you really want to do a radical and disruptive transformation, then you're talking about fundamental systems. It helps when we help organizations to progress on their journey towards digital transformation. It's helped to use a kind of a typology like this to understand what the challenges are, the scope of the challenges, and the breadth and depth of the behavioral changes and human changes that will be required to support the technological changes. So the typical digital transformation journey that we would work in with a company would be to plan, make, sell, and operate, to develop the strategy, make the services and products required for the transformation, then understand the customer engagement based on that transformation, and then finally roll it out and operationalize the digital transformation. So this is the typical life cycle or engagement model that we would have with a company. And typically we would get into quite a lot of detail around the different strategies associated with those 4 steps. What's required to plan and execute the digital strategy? what are the make or buy decisions around services and products? What are the marketing implications if you want to have an engagement model, successful engagement model through digital channels, and then the building out and the operationalizing of those digital operations. So these would be kind of next level of detail. And each one of these bullets would have a whole host of modeling support and analysis to help organizations execute their journey as effectively as possible. So an example of one large financial services organization that we worked with, we did a kind of a longitudinal study of where they were back in 2010 as they started their digital transformation journey, and where they've got to in 2026 in their journey in digital transformation. And we've characterized these as a number of activities. So back in 2010, the information technology department was really a support function. It was a secondary activity to support the main business of the company. But what we're finding after digital transformation in this company is that technology is now core. It's core to the strategy. It's not just a support function. We've moved from a model of the annual planning cycle with a very disruptive and significant change to a model where we have continuous improvement and rapid innovation cycles and agile performance and practices generally. We went from a model where we had a kind of a siloed or a separation between the business function and the IT function to a very much integrated cross-sectional team involving multidisciplinary performers from IT and the business. We've gone from bespoke, customized, highly designed and uniquely crafted systems to platforms where there's a big emphasis on reuse and APIs. We've gone from specialism to tech engineering talent in-house. And as you can see, I suppose the general trend has been IT becoming more pervasive and becoming more central to every aspect of the activity, including experimentation and innovation. Organizationally, then we've moved, this organization in particular has moved from a hierarchical functional structuring and governance model to more of an organic, flatter structuring governance model where things are not quite so separate. And as I said, we moved generally from waterfall to agile, and this data governance situation where everything was slow and limited and siloed. We really do these days pay much more attention to enterprise architecture and data architecture so that platforms with fast vision of data right across the organization is the expectation. So in summary, what we found using digital transformation methods and helping companies make that transformation is quite a significant change. Certainly since we've started helping companies in this area. Okay, so we've talked about the emergence of technologies generally and the different waves and the history of those waves. And then we've described the impact of those technological waves on digital transformation. Now I'm going to talk about AI as an example of the emergence of another technology and see what we can learn from previous technologies about this latest one. In academia, to do with technology management, we have many models and frameworks and ways of describing how new technologies come to being. On the top left-hand corner, as I look at it there, we've got the Rogers diffusion curve. And this is a way of describing how a technology gets diffused across a society. So at the very early stage, you'll have very innovative people, very early adopters who want to use the technology, even though it might not be mature, they still want to use it anyway. And then you get early majority and late majority of users will follow on from those early adopters. And then finally, you'll get people who are slow for one reason or other, who are late in adopting that technology. So this Rogers model is a very helpful way of describing the diffusion of a new technology across society by identifying who the early adopters are, the people who are willing to take a risk on a new technology, and then describing who the late adopters are. And by the way, it's not always a bad thing to be a late adopter of a technology, because if you're a late adopter, it means that a lot of the problems might have been ironed out before you got to the technology. And a lot of some sectors like financial services or health or other sectors are very highly regulated, and it's not possible legally to just adopt the latest, greatest technology. You have to be very careful about how you adopt technology. That's one way of thinking about technology adoption, is that Rogers model. The model to the right of it is the S-curve model that describes how technology gets adopted slowly, and then eventually people get return on the investment in that technology, and ultimately it gets obsolete, it gets out of date, and then new technology comes in and takes its place. So it's a kind of an S-shaped curve, and it describes how one technology takes over from another technology and goes through similar type of growth phases. The model on the bottom left is Christensen's model that describes how different products can have a disruptive effect on a marketplace. So if a new technology arrives in at a completely different price point, it can disrupt the current incumbents in the market and create a whole new performance trajectory. And then finally, we've got Moore's chasm that describes how, particularly for early companies, spin-outs, companies who are on their early stage of development, it can be quite a challenge to get from that early deployment to a scaled deployment with significant cash flow. It's called the valley of death, that period of time where you have a prototype for a product, but you don't have enough sales at scale to get to the point where you can have mass deployment of the technology. So there are many ways of looking at technologies as they emerge. These are just four of perspectives that I'm using here as an example of how you might like to think about framing or researching or characterizing a technology as it evolves over time. So as I said, Rogers curve then has this view of things where you've got early adopters, you've got the majority of people coming later, and then finally you've got the last people to adopt technology. So if we think about this way of looking at technology and apply it to the different industrial revolutions we've had over the years, we can see that the time involved in adopting a new technology is shorter each time. So that first industrial revolution took 85 years before it reached mass deployment. The second industrial revolution took half as long, 44 years. Third industrial revolution with PCs, digital and internet and so on, 28 years. So the prediction at the moment among the technology management academics is that we'll see this current revolution that we're in have this much shorter deployment time. And that has, of course, has a lot of implications for learning and for debugging and deploying technologies successfully. So again, the point here is that these new waves of technology, we've got less and less time to deploy them successfully and exhaustively. So if we look at AI, for instance, one characterization is this type of a model where we're potentially looking at a peak in 2028, and then starting to see that drop off for late majority and laggards after that period of time. This is applying this technology management framework or view to AI. So what's the problem? Why are businesses having difficulty in adopting AI? And this is the result of an analysis across a wide range of companies. I guess it won't be, well, I don't think it will be a surprise, some of these things. One first concern there is a lack of trustworthiness and transparency. So that people are concerned about what the quality of the output. Secondly, people are concerned about cybersecurity, concerns about IP infringement, concerns about legal issues, regulatory issues, explainability, the understanding of how those decisions were arrived at or those recommendations were arrived at. There are lots of concerns about individual privacy, personal privacy, and of course concerns about skills and labor displacement. So these are all perceived to be risks or factors that are slowing up the adoption of AI across businesses. And when we look at this a little bit differently in terms of what was the impact of these issues and what was the frequency of occurrence? So I guess the worst place to be is on that top right-hand corner where you've got a very serious impact and you've got it happening a lot of times. So the top right-hand corner, that point about poor data quality is significant because it's saying that organizations are seeing that has a very high impact when it happens, but it also has a high occurrence as well. So it's not a good place to be. If you look at the left-hand top corner, AI solution did not work. That's a huge impact, of course, but it didn't happen as often. So these are the types of failure mechanisms and problems associated with AI deployment. Another issue with AI that I'd like to bring to your attention is I think it was last week or 2 weeks ago, I saw that the number of commercial transactions on the internet made by bots, made by agents or non-human activity is now greater than the number of commercial transactions made by humans. And this is sometimes people call it the death of the internet, that back when the internet was designed, it was designed as a place where humans could share information. That was the original design goal when it was when the original internet FirstNet was put up in Switzerland, in CERN. The design goal was to help engineers communicate with one another. But what we're seeing is that the internet is increasingly dominated by algorithmically generated content rather than genuine human interaction. So this raises questions about, what is the provenance? What is the governance of the identities? Who are these? Is it humans that are executing these transactions? Is it bots that are executing these transactions? And it's not so much that the internet is actually dead, but it's going to become a challenge, and it really is a challenge, I think, to distinguish between human communication from machine-produced content. So you can see how this raises significant questions about trust, misinformation, and how people would interact in a confident way in the future. So what we're seeing is a gradual move and a concern about governance. We're probably all familiar with the challenges associated with data governance looking at how the data, the quality of the data, how it's generated, what's its life cycle, how it's managed, how it can be traceable, and so on. But we're moving into an era where organizations are worried about AI governance. How do we look at how models are developed, how they're validated, how do we mitigate bias in decisions, how do we detect hallucinations, and the whole area of digital slop and bad information coming from AI systems. So I think as companies move from the data-centric view of the world in their digital transformation journeys, they're starting to encounter these AI governance challenges, whereas in the past they were concerned solely with data governance. Okay, so I'm going to move on to what all this means and what are the potential implications of some of this for my view of the future of work. And, there have been a lot of recent surveys on, what professions are most likely at risk and what professions are safer in the advent of AI. And generally speaking, as you see on the left-hand side there, professions that require a lot of human interaction, a lot of human sensitivity, a lot of creative practices that are embedded in places and in context and in people's individual crafts and skills. They are likely to be the least risk of being transplanted by AI. On the other hand, tasks that can be highly automated and where the human touch or human in the loop, as they call it, where humans can be removed from the loop, that those tasks are likely to be more high risk in terms of potential displacement. So, there are different views on this. Some pessimists would say that, it's large-scale job losses and there's going to be a rupture in the labour market and much more precarious work environments. Others be more optimistic will say that there will be a whole new types of jobs out there that we don't even think of yet, we haven't dreamt of yet. So it's not that long ago that nobody heard of the job of a prompt engineer. So whole new areas of professional endeavor might emerge from this. So some people are not as pessimistic. I think the challenge is that there are a lot of moving parts here, and it's very hard to have a research methodology as an academic to identify what the outcome is going to be. There is increased unemployment potential for sure. There seems to be the potential there for polarization, societal polarization, and for more precarity in work practices. And policymakers and national governments struggle with this and are struggling with this. In Europe, we tend to pay a lot of attention to regulatory compliance frameworks and ethical AI legal issues. In America, that's not so much the case. They have a much more laissez-faire, much more entrepreneurial view, and less concern with compliance and regulatory issues. And then there's also quite a lot of challenges around the potential for large corporations to influence societal change. And I guess that the question that comes up is, if you look at 3 or 4 large technology companies that are driving AI, do they really have societal values at heart, or are they driven by the profit motive? And in many cases, they are driven by the profit motive, and they will resist regulation as possible. So it's all to play for. It's certainly not predetermined, and is often quite context specific. I'd like to just finally that maybe what we need to think about in the future is where will be the potential for human agency? Where will be the opportunities for work and for profession that will be most difficult to be displaced by AI. One such topic that's gaining a lot of interest in my country, where I come from, is creativity. There's a lot of attention being given to creativity as a key critical skill in professional development in the future. And there have been some critics of our educational systems, our university systems, that we haven't done a good job of provoking and providing creative skills to our students. In fact, some people would say that we actually diminish people's creativity once they go through the university process. Globally, there is a growing and very huge potential for the creative economy, for creative industries, and a lot of attention, particularly as I see it anyway, where I am in Europe, around this as a focus area for the future of work as a complement to the development of AI tools and technology. Okay, I'd like to talk briefly about what's the difference, for me anyway, between human judgment and the kind of judgment you see in LLMs or in AI. On the human side, you've got, our senses, our information from social contacts, our experiences and our perceptions. Whereas on the AI side, it's more to do with textual input and tokenization. Whereas on human judgment, we're depending on our memory, on our experiences, on our motivation, our emotion, our reflection. All of these are very human skills, very important skills when you're making a judgment call, when you're making a decision. On the other hand, when you look at LMLs, they're looking at pattern recognition, they're drawing statistical conclusions, and they're making integration in a result that creates a probabilistic outcome. Whereas in human judgment, we're quite value sensitive, quite context dependent. So I'm drawing this distinction because I think the future of human work will be leveraging those skills and talents that are particularly human. And the question has been asked: can AI be creative? And I really wonder. I would question, and I think there are issues around creation and generation. Are we just generating new data? Are we actually creating new ideas? Is the ideation process true, or is it just a generation of random thoughts? The process of creating new ideas versus the outcome. At the moment, we're very focused on the outcome in the AI world, but there needs to be equal attention to the process of idea generation. Novelty. What exactly is novelty? In the academic world, we tend to think about theoretical novel ideas, but in the practical world, in technical skills and crafts, we're looking for other types of originality, other types of novelty. And context is really important. I think human cognition is contextual. We are all situated in our cultures, in our localities, in our groups, in our organizations, and that is shaping us, our interpretation, our problem solving, and our making of meaning. It's different in AI. That's a different type of creative process. So my provocative question is, can AI be creative? Maybe someday, but I think there are some significant challenges along the way. So we have a lot of focus then on skills and development of abilities around creative industries. I'm going to very briefly now just talk about, lastly, a project that we're running in Ireland called Creative Campus. And this is where there will be a national framework for creativity right across the third level sector, across all universities. And we're doing this as a nation because we feel that creativity is a key for our future. We have developed this idea of what a creative campus is. It's the idea that students, staff, administration, leadership, everybody gets involved in creative processes and creative activities. And this came from a government initiative called the Creative Youth Plan. So it's been driven by the Prime Minister's Office as a key activity for the country. So the framework that we've developed talks about how you can, as a university, lead and manage a creative activity. What are the key enablers to make that activity successful? And what are the domains that you want to be successful in terms of creativity? And the domains are, teaching, learning, and research, obviously. So that's an example of a national framework that we will be releasing in the next month, September, across the university sector in our country, because we believe that creativity is an important aspect of the future of our society and the future of our work. Finally, I just, AI is important, but it's not the only technology that we need to think about as we go forward. That particularly grabs my attention is quantum computing. So the predictions are that quantum computing will become scalable by 2030. If that's the case, that will have a disruptive, transformative effect on our computing infrastructure in our society. I see what encourages me to think that this might be real is that we're starting to see startups like Quantum Motion that have now the ability to deliver quantum computing on a chip. One of the big challenges about any technology is that it will not really become scalable and deployable until it's cheap enough. And in the case of quantum, it won't become scalable until, in my view, it won't become scalable until it becomes a solid state transistor. And we're starting to see the first examples of that happen in venture capital companies. And I see just a few months ago, the UKRI, their National Quantum Computing Centre, have developed the first set of guidelines for ethical and responsible quantum computing. So this tells me that this next wave might be not as far off as I had originally thought. And of course, many interesting innovations and changes will come at the intersection of these new technologies. So the really interesting question will be, what will happen to AI when it's run on quantum computing? Okay, so that's my very whistle-stop tour through the emergence of new technologies, how we model those new technologies, the application of those types of models to artificial intelligence, the implications of artificial intelligence for future work. And then finally, just a reminder, I guess, that there are other technologies also emerging that would have a very significant effect on society and in the organizations that we work with. Thank you very much.